This is an acute triangle. So is this. And so is this. It's like calling your friend John and three different Johns turn around. We can't really tell who's who. So by the end of this video, we'll discover different naming formats for triangles and why some are better than others. To start creating triangles, we head over to Paperland by clicking the link below. Click Enter Paperland, enter in your name, and remove all the code on the left to begin. In order to draw a triangle with our arrowhead, we need to know three movement commands: to move forward, face right, and face left. Either click the commands on the right or type them out manually on the left. Scroll up to zoom in. Playing around with the movement commands allow us to draw a triangle. Here we have 6 pieces of information, the lengths of 3 sides, and 3 angles. String these information together and we get a unique name to represent this triangle. Go ahead and try creating this side 50, angle 90, side 50, angle 45, side 70.7, angle 45 triangle yourself. Whew, that's a really long name. Reminds me of a brother named. Let's shorten it by using the letters S and A to represent side and angle. Now, it's called the S50, A90, S50, A45, S70.7, A45 triangle. It's still a mouthful to say. Any ideas on how we can shorten this name? One thing you may have noticed when drawing the triangle yourself is if we removed the information about the last angle, we are still able to complete our triangle. This means we only need 5 instead of 6 pieces of information. Are there any other unnecessary information we can remove? What if we only have 1 piece of information? There are only 2 possibilities here. Either we know the length of one side or we know one of the angles. Let's investigate only knowing one side first. Start organizing our tabs by naming this 1S and assume one side of our triangle is fixed. Adding a hashtag here represents a comment. We can see that we are able to draw a completely different triangle even if one side is fixed. This means that only knowing the length of one side isn't sufficient for us to create a unique name for our triangle. So we cross this out. How about if we only use one angle? Create a new tab and call it 1A. Again, we try to draw 2 different triangles while having one fixed angle. Once again, we're able to do so, which means one angle doesn't work too. That's all the possible ways to use one piece of information, and it's just insufficient to help us uniquely identify triangles. We move on to investigating 2 pieces of information. What are the possible ways to arrange them? Take a moment to think about it. There are 4 ways to do so: angle side, side angle, side side, and angle angle. Let's investigate angle side first. In a new tab, we create a triangle where one angle and one side is fixed. A little trick here is to use the fill and B color commands to make the fixed angle and side more obvious. Once again, we're able to create multiple triangles despite having a fixed angle and side. This means we can cross out angle side as an option for our naming format. We can use the same rationale to cross out side angle too. Why is that so? That's because angle side contains the same information about a triangle as side angle. If you don't believe me, we can compare the evidence against angle side on the right in yellow and side angle on the left in green. If we rotate them about the z-axis, you can see the proofs are exactly the same. The order doesn't matter in this case due to symmetry. So now you know, we can cross out SA2. What about side side next? In a new tab, we create 2 fixed lengths. The go-to command is a handy trick to not have to figure out the third length directly each time. If these 2 sides are kept constant, it means we are free to vary this angle. We can easily draw another triangle with this side-side constraint. An even better trick we can do here is to double-click this angle to bring up a slider. Drag and see all the infinite ways we can draw a triangle if we know the lengths of two sides. And since it's infinite, clearly side doesn't work as well. Our final option is angle. If we take a look at our previous example 1a, we can see both triangles share this angle, and since this angle is 90 degrees for both triangles, that means that the angle condition is fulfilled. Yet two different triangles can be drawn. In fact, we can draw even more triangles. Did you manage to spot a trend while creating these triangles? Notice how the angles all stay the same and we only change the sides. If you were to look even deeper, you may realize that the sides are all changing by the same amount. This means we can simply add a multiplier on the sides to create our different triangles. This is quite a lot of code, so I'll introduce another trick, where we create our own custom command. First, highlight the code for the triangle, then name our command triangle, and click the icon. There you go. Now we can type triangle as a command. As we have mentioned before, all the sides scale by the same amount. So I'll add a variable here called scale. Then multiply every forward command by the variable scale. We can then indicate how much to scale each triangle by. Every triangle here fulfills the angle naming constraint, so we can rule out angle as well. That's all the possible two-piece naming formats we can have, and none of them allows us to uniquely name triangles. We have to move on to 3 pieces of information. Quick question, how many possible ways can we arrange these 3 pieces of information? Well, there are 8 possible ways. This seems quite scary, but at the same time, it's where the real fun begins. We jump right in and investigate AAA, and we strike it out immediately. The reason for doing so is the same as for AA. That's because the sum of interior angle formula dictates that if we know 2 angles in a triangle, we can always calculate the third. Check out this really cool visualization on why the sum of interior angles in a triangle is 180 degrees. Let me know if any of you want a separate in-depth video on how to code this using all the tools you already know. Next, we can compare the options and cross out a few more. The rationale being that ASS is the same as SSA, and AAS is the same as SAA. This is all due to the symmetry property we have explored earlier with side angle and angle side. Very quickly, we're left with just 5 options, and that's not too bad. Let's tackle ASS next. Interestingly, if you experiment with getting 40 different people to try and create random triangles using ASS naming, you'll likely get 3 different buckets of people. One group claiming, yes, it works. One group saying, no, it definitely doesn't. And the last group just gave up trying to draw triangles at all. How did this even happen? Why would some give up on trying to draw a triangle? Well, let's try it out for ourselves. We set up the first angle with the fill command and a dotted line. Then add 2 fixed sides. Now, we just need to find a way to connect this line to the dotted line. The variable we can play with here is this angle. Using the slider, it seems like there's no way for the lines to connect. To be more certain, add a circle to see all the possible ways the line can turn. We see that the circle never ever intersects the dotted line because this side is too short. There's no possible way for us to form a triangle based on the given SSA information. No wonder this group gave up drawing a triangle. What about a group that was certain ASS wouldn't work as a naming format? What were the conditions which led to that conclusion? We used the same ASS setup as before, except this time, we ensure that the side is long enough to cut the dotted line. And there you go, we've successfully made a triangle this time. But it seems like the circle cuts the dotted line at 2 different points. Does that mean that we can form another triangle at that point? Yes, turns out we can. So the same ASS naming can be used to refer to two different triangles, and we won't know which is which. No wonder this group struck off ASS as a naming format with certainty. So why did this last group claim it works for them? We construct the same ASS setup, but this time, the fixed angle is set to be larger than 90 degrees. By drawing the circle again, we can see that the circle cuts the dotted line only once. That's due to the fact that the center of the circle is to the left of the starting point. This means there's only one possible triangle that could be formed from this ASS setup. So this group was correct as well, based on their starting conditions. Looking across all three groups, we can identify the conditions for ASS to work. First up, the length of the side has to be long enough to reach the dotted line. Second, the angle in ASS has to be more than 90 degrees to ensure only one triangle is possible. These conditions make ASS quite a pain to work with. Hopefully, the SAS option is better to work with. The setup for SAS is rather straightforward. We basically need to find ways to connect these 2 points. Well, there's only one way to do it with a straight line. That means that this is the only triangle we can draw. So, if SAS is as short as it can possibly be with 3 pieces of information, and it can only be used to describe one unique triangle, then ta-da! We've found the perfect way to name triangles. There are 3 more possibilities left to explore, but I can't have all the fun to myself, so I'll leave these to you to play with. Although we have found the perfect way to name triangles with SAS, it was actually all the wrong twists and turns we ran into along the way that led us to explore numerous exciting ideas. Imagine the things we miss out if we were only told the correct answer is SAS. P.S. If you're a math teacher, let me know if you're interested in lesson plans we've designed that brings these exploration ideas into the mathematics classroom. And for those of you who have stayed till this point, here are some bonus things we've discovered while exploring triangles but didn't make the final cut. Enjoy! How did these triangle spider legs make a circle? So this is triangles stacked together in 3D. Ooh, wow. That's nice. Holy